Hello, and thank you for watching B-Sides. My name is Sebastian Kramp. Today I want to show you something about splunking a horse. So the first question at this moment is, do you see a horse somewhere? Well, I think here is one. It's Buttercup. But yeah, we can splunk Buttercup herself. So, who of you knows why there is a horse as a mascot of Splunk? There is a story behind. The story was in the early days when Splunk was founded. You can also read it in the internet, or there's also a small video. There you can see there are some guys on talking about the early days, and somewhere there was a programmer there, and the programmer was a really brilliant guy, and well, the programmer doesn't want to work 5 days a week and so on. Because yeah, he didn't want. But the founders of Splunk, they really wanted to have him as a programmer, and so they asked him, well, what can we do so that you'll be here for a longer time? And then he just said, well, I just want to have a pony. So then someday someone went through a mall and had seen a really big, great pony. Then he decided to buy this pony, and then this pony was packed into paper and was placed next to the desk of this programmer guy. And the next day he came into the office. He had seen this gift for him and unpacked this gift, and there was the pony he just wanted to have. And so the pony got the mascot of Splunk. The name Buttercup was because the original pony name was Butterscotch, but then it was the name was replaced to Buttercup. And so Buttercup as a pony from then on was the mascot and the logo of Splunk. I hope my conclusion was correct. I posted the link for the original video here. Today I want to show you something what's a bit special. So I just have splunked our horse. And how we can do it, I will show you in a few minutes. It wasn't so easy to splunk this Buttercup, so I've chosen this one. To understand the project a bit better, there is a map. As you see in the top, there are 2 riding halls. Yes, it's, you can say one hall, but they're divided in the middle. Then you can see there's an outdoor riding place, a walker. What the walker is, I will tell you later. Then in the middle there's a stable where the horse is at night, and the pasture where the horse is on day. In the beginning of the project I was thinking of data which is collectible. I thought, well, I could take GPS data, I could take weather data and water consumption. So I started to build my first GPS sensor. To get power, I've taken a normal power bank. As a microcontroller, I've taken an ESP32, and I plugged in a normal GPS sensor you can buy in each online store for electronic. With this device, I would have really granular data each second, for example, and then I thought I could send this data by Wi-Fi and LTE to my Splunk instance, and I just wanted to do everything by hack. But the problem I've seen really fast was when my horse went away from the stable to the pasture. The Wi-Fi device tried to send its data, but it was out of range. And while there's no buffer on my ESP32, the data can't be sent, and so it was not usable for me. So the next option was to take a Raspberry instead of an ESP32. I could also install a universal forwarder on it, so I've got a buffer, the thing I haven't had before. I have the same granular data because I could take it each second. I've taken the same power bank, and then the forwarder should send its data by Wi-Fi and over my LTE router to my Splunk instance. Everything looks fine, but suddenly I have had another problem. Believe it or not, like in each good environment, there we have a test environment. So I've put all the things on my test horse, and then this happened. It lay down on the ground, and I don't have to tell you what happened with all my electronic devices. Shit happens. So my third idea and final idea was to take a GPS tracker, which is normally built for dogs. This tracker is a small device which you can put somewhere on the horse, for example, and it will send its data all time when it's moved, in this case each minute, to an cloud instance. This happens because in this device there is a small card for mobile phone, and so it can send its data, and I don't need to implement any components which will send the data to my Splunk instance. My Splunk instance itself will collect the data via API from the vendor. The pros, of course, are that this device is very small. It is for outdoor usage, and if the horse lays down, it won't be destroyed. It needs very less power, but as mentioned, I don't get the data as fast as with my pre-built or custom-built GPS sensors. In maximum, I get the data each minute, and of course I need this abo for the cloud service, which isn't for free, of course. To get this data via API, I of course could build something by my own, but while I have a smart home solution at my home, there is a pre-built software thing which collects the data from the cloud, so I have chosen this one. It was the easiest way, and yes, it works really fine, so why should I build something other by my own? Also, authentication and so on is implemented. After I have found my solution for the GPS data, I started to work on the water sensor. Therefore, I bought a flow meter. The flow meter should be placed on the system where the horse drinks its water. The flow meter will be plugged onto an ESP32, and this ESP32 will send its data via syslog to a Raspberry Pi. On the Raspberry there is a universal forwarder, and on the Raspberry there is also an LTE stick, so I can also send my data via mobile system to my Splunk instance. I have granular data each second and also a buffer, so that means if my connection is lost between my Splunk instance and my universal forwarder, all the data will be stored on the Raspberry. Getting the weather data was quite easy because there are many websites on the internet which are showing the actual weather, and so I've built a small script which collects the data. I think it was each 15 minutes. It was granular enough to get temperature and all the things which are shown on the website. This is done by my Splunk instance at home. I'm sure now you will know how this measurement of water works. I will show you. So, when the horse wants to drink something, it puts its mouth here and water comes. And as you see, here there is a flow meter. And so you can see, or you can do the measurement how much water goes through the pipes. Our horse, of course, isn't all the day outside and all night just in the stable. It will be also trained. And there is a small app which is available for iPhone and Android systems. It's called Equilab, and this application is used to track the riding. So that means each time when you're sitting on a horse and you're riding, it will collect data like GPS data, gait detection, and so on. All the data will be sent also to cloud services, and then you have the possibility, if you have the full package, to get those information by an export, and then you can also implement this data into your Splunk environment. The only disadvantage is you have to manually start and stop always this application. Now let's start with standard horse analytics. Let's do a small recap. Now we get GPS data from this small GPS device. So we have the movement when the horse is outside, and we have the movement of the horse when it's in the walker. The flow meter itself will detect the liters of water the horse drinks, and with the riding app we have the gait detection, also GPS detection during the riding, and the tag of each gait will also come with this application. Even with the flow meter, I was able to figure out how much water our horse drinks. And as you see, the horse is drinking around about 33 liters a day. Normally a horse should drink between 25 and 40 liters, so everything is fine. Then I created a new statistic which is calculating the average sum of water in liters which is drunken in each hour. So as you see, there is a big peak at around about 7 o'clock. This is because my wife is each morning at the horse stable and rides the horse between 5 and 7 a.m. Yes, it's right, a.m. And so when the horse finished its work, then it's going to drink something. And as you see, and the rest of the day, when it's a bit warmer, noon, then it's drinking a bit more, and as you see, at night hopefully it sleeps. This measurement was done during the winter times, so the horse wasn't outside on the pasture, so I was able to track the drinking behavior 24 hours, except when it's not in the stable because it's in the training. As you know, more value comes out if you put more information into one diagram. In this scenario, I have the information how much liter our horse drinks, the information if the horse is not in the stable because my wife is there for riding, and I also have the temperature with this line, as you see. The pink lines which are down from the 0 line are the tries, how often our horse tries to drink something. On this special day, at around about 10 p.m., the temperature went down under 0 degrees, and you can see the horse was able to drink something, but when the temperature was under 0 degrees for longer than 2 hours, there won't come any water anymore to the drinking station. On the next morning, at around about 9 a.m., the temperature went above 0 degrees, and as you see, it took around about 2 hours until the water comes again through the pipes. All the time when the water wasn't available, you can see the horse tries to drink something, but no water came out. This was just a coincidence, because if no water comes, the flow meter won't work, but in this situation there was so less of water that even for a second the flow meter tries to rotate, and then I could see that the horse tries to drink something but no water came. So from now on I can write an alert for my wife. If the temperature is under 0 degrees for more than 2 hours at night, she can take some bottles of water to the stable to the horse to give him something to drink. I'm sure not every one of you is familiar with the walker. So I just want to show you what a walker is. It's this one. So what to do with this? We put in a horse, or some horses, and then they go round and round in circles. This device will turn around sometimes new horses will come in, sometimes other ones go out. Now we have enough data to summarize how much kilometers our horse goes a day. The information comes from the riding application, because there we can figure out how much kilometer it was walking, how much kilometers it was in trot, and how much kilometer it was in canter. The kilometers in the walker are just a best guess. The problem in this situation is the GPS information will come each minute, and as you know, the GPS signal isn't that exact. Also, the problem is the walker will sometimes turn around from the left rotation to a right rotation, and another problem is sometimes it will stop because other horses will go out or go in. So I have had the only possibility to check how much kilometers the horse is running when it's in for around about an hour. I know the size of the machine, I know the speed of the machine, and so I can see it turn around every 6 minutes, and well, there's enough space for 8 horses, and so there will be 8 stops. So I was able to figure out how much kilometers it will go when it's there in for an hour, and then I can just scale the information up and down. If you have the information for 1 hour, you know also the information for a minute. As mentioned, during riding we also have BPM, so we can see over time if the takt will be the same or if it changes. This is just interesting if you do a very, very long time analytics. That was standard or basic stuff. Have you ever heard of deep horse analytics? While we have long time data, we can compare data. So unfortunately, our horse was sick for a longer time. And then I was able to figure out if the horse is healthy. It was drinking 33 liters as mentioned before. And during the horse was sick, it was just drinking 30 liters in average each day. I also figured out our horse is lazy. Yes, it's totally clear. If it's warmer, it will go on the pasture less kilometers than normal. But here you see it's really like this. It's warm, so less kilometers. It's going to be colder. It's going more kilometers a day. My wife trains horse every day. So there are several possibilities how to train it. And I think each of you knows what riding is, of course. She can do it in the halls, and we have a big hall and a small hall. There she can do riding, of course, and she can also put the horse onto a rope, and then it runs in circles around her. And I will show you how we can see what she has done, and how we can use machine learning toolkits to figure out what she's done only by the GPS data. Here you see examples from the Equilab app where my wife was riding her horse or when the horse was lodging. So as you see, on the left side the whole hall was used, and on the right side there were circles which were a bit smaller, and in the beginning of the training she used the whole small hall, but then she was doing the training on the lodge, and so you see most data points are just in the middle of the right circle. As a human, we can see which type of training the horse has done, but I just want to have the machine to figure this out. So the idea was to take the average of all latitudes and all longitudes to figure out what's the point in the middle. The lodge itself is 10 meters long, so the maximum distance might be, let's say, 50 minutes from the point in the middle. When we are doing riding, we are using the whole hall, and as you see, the hall itself might be more than 40 meters, and then if the data points are more than 20 meters away, we are doing riding. So there comes out a table like this one with the description what is done each day. Then we have taken the machine learning toolkit, have chosen the random forest classifier, and out of the latitude and longitude data we were able to figure out if my wife was riding the horse or if the horse was on the lodge, or also where she was riding. But as you know, random forest classifier is a supervised learning, so everything what we have done before was the pre-work to have such a great result. But what if everyone would do this? You can Splunk if each horse is healthy, if it has done enough work, if it was out or not, how it was trained, and so on. But you could also check if the horse are free for riding, if the walker is free for my horse, and so on. So let me show you what you could do with this in the future, for example. I'm pretty sure you have never heard about stable service intelligence. In this case, I've built in ITSI all my stable as one service. This stable has two deeper services. One is horses and the other one is infrastructure. Each horse is, in my case, an own service, and you can have your own KPIs. What does this mean? So I will build KPIs like, is my horse going the kilometers it should go on the day? Is it more or less than normal, of course? The same with the water. Has it drunken more or less? What's normal, what's not normal? And also with which method it was trained. Well, after that you can build, of course, a service template and put this template on all horses you have. It's just an easy thing. The same is with the infrastructure, because we have two halls and you can just figure out how many horses are in each hall at the moment while they are all sending GPS data. It's just a normal counting. If you summarize the information by each hall, you can see when is the best time to go in, when are less horses there, so you have more space. The same with infrastructure. Build a template, put the template on the halls, on, for example, also the outdoor riding, which is missing here, but it's easy to do. Of course, this is more like a joke. My farmer hasn't implemented this. But where is all this for? For a private use case, there's, for example, the detection of work. You can figure out how a horse was trained and which training type it was. There is a duration, there is a takt, and so on. You can also figure out how hard the training was because of duration and how much time it was in trot, how much time it was in canter, and so on. Well, as a future project, I thought maybe I can take the health data from my wife and then I can figure out how hard the training was for the horse and how hard the training was for her. So, detection of water consumption, where is this for? For example, of course you can detect if there are leaks of water pipes. This sometimes happens because in the winter when it's cold, the pipes will break, so you have a prevention of damage, because if the pipe breaks, then you can see the water goes through and everything will be floated and will destroy all the other stuff which is lying around. Of course, you can also detect if the horse could be sick or not. That means the wellness of the horse is also detectable. Just as an idea, think big. For an enterprise use case, for example, you can have a 360-degree view of the stable by using the stable service intelligence. Funny idea, isn't it? So let's review some stuff. First of all, be creative. Free your mind out of IT. There are so many things which are Splunkable, and it's interesting how you can find dependencies. The other thing is seek the challenge. Don't think it's not possible. More things are possible than you suppose and in the first moment. There's also so many learning by all those projects you're trying by your own. Because by challenging yourself, you will learn so many things you will once need in the future. And of course, have fun. It makes fun developing and seeing the project going bigger and bigger, especially when you find people who are telling you that won't work. And also there's so many interaction. Interact with all the parties, developer, users, owner, and talk about this with other enthusiasts. I was also very surprised when someone came to me and was talking to me, well, you're the guy who's Splunking his horse. That means many people were talking about it before I've shown this here at B-Sides. This is the next part. Show what you have done, because I think there are many people who are just interested in it and want to see what you have done or want to have technical knowledge. I hope you have had some fun and enjoyed the session. See you soon.